In this video, I will discuss frequency tables and the related concepts of frequency, relative frequency, and cumulative relative frequency. So the university has done a survey about students' views of the dining services, asking everyone to rate the services from 1 star to 5 stars. So they surveyed 50 students in their sample and they got this list of responses. I'm not going to read them all out, that would be ridiculous, because the problem is that this list is just hard to interpret as it is. Now, in short, we're missing the forest because of the trees. So, what can we do to summarize this data in a meaningful way? A reasonable first place to start is to use a frequency table. A frequency table will display how much of the data falls into a particular category. In general, a category could be a qualitative trait like eye color, a specific quantitative value like a star rating, or a range of quantitative values like test scores from 70 to 79. The frequency table includes 3 or 4 columns, depending on the specific data that we're looking at. These are the category or group, the frequency for that group's relative frequency, and for ordinal, interval, and ratio data, that is, any data where the groups can be put in a meaningful order, the cumulative relative frequency. Let's define each of these. Frequency is a measure of how many observations from our data set fit into a particular category. We'll look at an example in the next slide. But as a simple example, I might have, say, 3 red starburst in a pack. In that case, 3 is the frequency for the category red starburst. Relative frequency is often more useful than frequency. It expresses frequency as a percentage of the observations, either in percentage or in decimal terms. So if there were 20 starburst in that pack and 3 of them are red, then the relative frequency of red starburst is 0.15 or 15%. While frequency tells us about the data directly, it will depend a lot on the sample size. It's not clear whether 100 is a big frequency or a tiny one unless I know how many observations there are. Because it's expressed as a percentage of observations, relative frequency has the same interpretation regardless sample size, since it's expressed, again, as a percentage of that sample size. Cumulative relative frequency, or CRF for short, is the percentage of observations that fit into that category plus all categories of lower value, or if you prefer, all categories of higher value. You can calculate CRF in either direction as long as you're clear. Remember, CRF requires at least an ordinal level of measurement. You need to be able to order your data meaningfully, which only ordinal, interval, and ratio data can do. So for red starburst, sorry, there is no CRF. Let's look at an example. Here I have 10 random numbers from 1 to 99. What I have here is a frequency table. For category data, we'd often have 1 line per category, so red, yellow, pink, and orange starburst colors. For quantitative data, we often will use a technique called binning, particularly when there's a wide range the data could fall into, so that giving each value its own category would result in a very large number of categories. With binning, we create bins that include values within a range. When making our bins, we typically want each bin to have the same width, though we might make exceptions for a bin of very low values and a bin of very high values. Here, 0 to 9 is the first bin, then 10 to 19, then 20 to 29, and so on. The first column shows the bins, which are our groups in this case. The second column shows the frequency. For reference, I've also included the specific data values, though this is not usually done. So we can see, for example, that between 0 and 9, we have 1 observation. Between 10 and 19, we have another one. Between 70 and 79, there are 0 observations. Relative frequency converts this to a percentage of the number of observations. So take the frequency in each row, divide by 10. That's the total number of observations we have. So, for example, between 30 and 39, we find 20% of our observations. Finally, the cumulative relative frequency shows the proportion of observations that fit into that category or one of lower value. So, for example, the 50 to 59 row shows that 80% of our observations have a value of 59 or less. Now, the decision to order this way depends on the case. This calculation of CRF is most useful if we want to know what proportion are below a particular value, or we can reverse it. Here, I reverse the order so that it's descending. We start with the high values, 90 to 99, and then work our way down through each row. Now, since high values are often a good thing, this is often the way that things are actually done. So if these were test scores, say, I could at a glance determine that 20% of my students earned a 60 or better on this test. You can do the same with ordinal data. For example, surveys with strongly agree, agree, neither agree nor disagree, disagree, and strongly agree. These options can be ordered in this way, from strongly agree down to strongly disagree, which would make it easy to find what percentage give an answer of agree or strongly agree, that is, agree or above in a sense. Here I have an example of where we've seen something like what I have on the previous slides, star ratings from Amazon.com. The bar here is just a bar graph showing the relative frequency, which is also stated as a percentage for each possible rating. Notice here they are arranged in descending order from 5 stars down to 1 star. Another thing to note is that Amazon does something that isn't strictly valid. They calculate an average number of stars. This is a common practice for this type of data, despite the fact that it isn't technically valid to calculate an average like this for ordinal data. However, I'll forgive them that flub, since they do show us the entirety of the data in terms of its relative frequency. So, back to the university's data. Rather than just listing out values, it's going to be much easier to digest the data in a frequency table, which I have here. Because there aren't very many individual values, I'm going to let each be in its own group rather than trying to combine them into bins. I used Excel to count the frequencies and apply formulas to calculate relative frequency and cumulative relative frequency. When I look at the data this way, what I see is that the most frequent response is at 4 out of 5 stars, with 15 responses, which is 30% of our sample according to the relative frequency column. At the same time, only 38% rate the dining as 5 stars or better, as we can see in the cumulative relative frequency column in the fact that we rated from 5 down to 1 star in terms of our ordering. Now, this might make me nervous, except that I also notice that there are a lot of 3 out of 5 star reviews. So 64% of ratings are 3 stars or more. So while the dining may not be exactly stellar, it's generally not seen as terrible either. Now, how worried the university is about that 18% of ratings that are 1 star is really up to them, but being able to look at the data in this way provides a much cleaner, more meaningful picture than just the list of individual ratings that we started with.